Have you ever wondered why the ocean tides ebb and flow every day? It's not just the gravitational pull of the moon, but a complex interplay of astronomical, geological, and oceanic forces that shape our planet. The tides are a fascinating and dynamic phenomenon that has intrigued scientists and explorers for centuries. Join us on a thrilling journey of discovery as we explore the secrets of the tides and how the moon affects Earth's oceans. Watch now to watch the stunning visuals and groundbreaking research and learn more about the wonders of our planet. What are the tides? A bigger instant effect would be on the ocean's tides, but to understand the impact we need to know about how tides work. Tides are the result of the gravitational tug from the moon and sun that the Earth feels. If we disregard the sun for now, the Earth's oceans facing the moon bulge up in response to the lunar gravitational force, a high tide. The difference in gravitational attraction on the near and far sides of the Earth means that at the same time, there is also a high tide on the side furthest from the moon. And because the ocean is liquid, between these two high tides there are two low tides. As the Earth is spinning, these high and low tides move across the globe over 24 hours, meaning each coastal location experiences two high tides and two low tides every day. Why a small silvery-looking sphere orbiting 384,400 kilometers away has a profound impact on us here on Earth. Although the lack of eclipses of any kind would be a sad loss, without the moon's glare, darker night skies would be great for anyone with a telescope. The full moon is 14,000 times brighter than Venus, the next brightest object in the sky. No moon would allow astronomers to enjoy pristine dark skies all year round. Only daylight, weather, and human-made light pollution hampering the view of space. For others, the outlook would not be so bright. Coral and certain species of crabs, worms, and fish can sense the moonlight from particular phases of the moon. They use this as a trigger to start species-wide reproduction. How they would react to a permanently moonless night sky is unclear. Tide times. A bigger instant effect would be on the ocean's tides, but to understand the impact we need to know about how tides work. Tides are the result of the gravitational tug from the moon and sun that the Earth feels. If we disregard the sun for now, the Earth's oceans facing the moon bulge up in response to the lunar gravitational force, a high tide. The difference in gravitational attraction on the near and far sides of the Earth means that at the same time, there is also a high tide on the side furthest from the moon. And because the ocean is liquid, between these two high tides there are two low tides. As the Earth is spinning, these high and low tides move across the globe over 24 hours, meaning each coastal location experiences two high tides and two low tides every day. In reality, it is a little more complicated. The moon's 27-day orbit of the Earth means the times at which high and low tides occur change. You have to wait 12 hours plus 25 minutes between each high tide. And the sun plays its part too. The sun's influence on tides is just under half as strong as the moon's. When the sun, moon, and Earth are all lined up, the sun and moon work together to produce spring tides. Though confusingly, they don't have to happen in spring. During spring tides, high tides are a little higher and low tides are a little lower than normal. In contrast, when the sun and moon are at right angles to one another, the tides from the sun partially cancel those from the moon, and we have the opposite, neap tides. Here, high tides are a little lower and low tides are a little higher than average. Without the moon dominating this picture, the Earth's tides would be much simpler, but importantly much weaker. The oceans bulge. The overall effect of these tidal forces is to squeeze the oceans and produce two tidal bulges on opposite sides of the Earth, one facing the moon and a slightly smaller one facing away from the moon. See illustration. Due to Earth's rotation, the two bulges act like two expansive waves continuously undulating around our planet. Topography causes variation. Mid-ocean, each tidal wave is just under a meter high compared to the water level of the two troughs between them. However, The variation between high and low tide is very different from place to place. It can range from almost no difference to over 16 meters, over 50 feet. This is because the water in the oceans is constrained by the shape and distance between the continents as well as varying ocean depths. As a result, the tides behave more like water sloshing around in an oddly shaped bathtub than in a smooth and even basin. In some places, the water flows freely and quickly, while in other areas, where the water has to pass through narrow channels, it moves more slowly. Continents affect tidal lag. While in theory, the tidal bulges follow the moon's position on its orbit around the Earth, the depth and shape of the ocean and the distance between continents are also important in determining when the tide rolls in and out. The time that passes between the passage of the moon and the onset of the high tide is called tidal lag. In the Southern Ocean, where tidal bulges can move relatively freely, the tidal lag may be around 2 hours. On the other hand, the tidal lag in the North Sea, a part of the Atlantic Ocean bounded by continental Europe and the British Isles, can be about 2 days. Perigin and apogin spring tides. Several times a year, the full moon or new moon happens as the moon is around its closest point to Earth, called perigee. This is popularly known as a supermoon and leads to an even larger variation between high and low tides, known as perigin spring tides. However, the difference from a normal spring tide is only around 5 centimeters or 2 inches. The opposite happens when the full or new moon is around its farthest from Earth, apogee, also known as micromoon. The apogin spring tides are around 5 centimeters, 2 inches, smaller than regular spring tides. In conclusion, the study of tides is an incredible field of science that has been studied for thousands of years. The gravitational pull of the moon on Earth's oceans has a profound effect on our planet's environment and is crucial for life as we know it. By studying the tides, we gain valuable insights into the complex interactions between the Earth, Moon, and Sun, and how they have influenced our planet's history. The latest advancements in observational techniques and theoretical models have allowed us to make great strides in understanding the mechanics of tides, but there is still so much more to learn. Subscribe to our channel if you don't want to miss our